Hi, I'm Zach Tarmina. This is Gordon Christie. This is Arvin Jaganathan. And this is Daniel Switcher. And our project is the snake robot. Here's a look at the snake robot that we have constructed for our senior project. The purpose of our project is to create a snake that is capable of moving without wheels. The reasoning behind this is because wheeled robots have trouble moving through rough terrains in small spaces, whereas our wheelless robot will be able to maneuver through these regions. Some of the applications used for our project are situations such as search and rescue, which a snake robot is currently being used in Japan for the tsunami disaster. Another application could be military purposes.
Our snake robot consists of 7 links of 2 servos, C connectors, multi-purpose aluminum brackets, and O connectors to connect each of these C brackets together. We have a customized head made of thin aluminum sheets to house our Arduino Mega boards. We have our camera mounted on top of the head so we can see what we're doing. And it's controlled by a Wii nunchuck.
Alright, in order to get the snake to move forward, what we did was we placed 2 grips in the back here that were able to push down onto the surface in order for it to push forward. And in order for it to slide into place, we used these felt pads here, which just allow it to not have a huge amount of friction that it can slide into place. Also on the head, we have 2 grips in the front and 2 felt pads in the back. This allows us to angle the head up, and when we're pushing forward, and it will slide easily, and place the head down when we want to pull it forward. Our original plan was to lift the head up so that when we push forward, it wouldn't have any friction at all. Unfortunately, the servos that we're using are unable to lift the head, so we had to basically push the servo down here to create an angle. The motion that we're using is known as concertina. It can basically just go into 2 different states, which we'll show here in a minute.
Alright, so for our snake robot, we basically had to use our Arduino boards, as mentioned before. Our Arduino uses the environment that comes with the board. It's just Arduino. The code used to write in that environment is similar to C++. Basically, it comes with a bunch of libraries that allows us to control the servos on our snake. Also, we managed to find more open source code that allows us to use a Wii nunchuck to control the snake in a very intuitive manner, just basically with using the joystick here, pushing forward, left and right to make it turn, left, right, forward. Also obviously, we use a Z button to change between using this camera mount here and controlling the snake. And if we are in camera mount mode, we simply use the C button here, if you can see, and that locks the camera in position so that way if you accidentally press the joystick, it won't move. With the camera, we have a basic GUI where it takes in the video feed and basically just outlines the face. It's very simple. And then once you click on the frame, it switches to motion sensing. And anytime you move, it will read it, and if there's enough motion, it will say there's definitely motion in this frame. And that's basically all for our software.
This here shows the Wii nunchuck controlling both the camera mount and the forward motion of the snake robot. As mentioned, the Z button toggles between the camera mount mode and movement. As you can see, the grips in the back are placed down as the snake robot is pushing forward, and the head is tilted up so that the grips in the front of the head are not touching the ground. The grips in the front of the head are then placed down, and the snake robot pulls itself forward into the mirror image of its previous position. This here shows the snake robot turning left. Since wheels are not being used and the grips are not perfect at holding the snake in place, the snake robot must turn gradually instead of making a direct 90-degree turn. Although the turning speed is slow, this still allows the user to angle the snake robot at a more specific angle. Turning right is very similar, only it's in the other direction. This here shows the GUI interface. As mentioned, a simple left click toggles between face detection and motion detection.